Have you ever wondered which aircraft can achieve the highest speed? Or which countries own these cutting-edge machines? Today we'll explore and count down from position 20 to number 1 to learn about the fastest and most powerful fighters in the sky.
20. Chengdu J-10 Mach 2.0. The J-10 is China's premier fighter jet, designed and manufactured domestically, with engines imported from Russia. Created to serve as both a fighter and a light bomber, it's capable of operating in all weather conditions, day or night. The J-10 officially entered service with the Chinese military in 2004, with several variants: J-10, J-10S, J-10B, J-10A, etc. The J-10 fighter is equipped with a Type 23 twin-barrel 23mm cannon, with a firing rate of 3,000 to 3,400 rounds per minute. It can carry 4,500 kilograms of weapons, including missiles and bombs, on 6 underwing and 5 underbody hardpoints. This new fighter can perform combat missions and dominate the skies on par with the U.S. F-16C or French Mirage 2000. The J-10B variant will be equipped with an active electronically scanned array (AESA) radar, expected to significantly enhance the capabilities of China's Air Force's E-favorite fighters. Currently, the Chinese Air Force has about 70 Chengdu J-10 aircraft. To meet full requirements, they plan to produce around 300 J-10A aircraft. It uses the KLJ-10 radar, produced by China based on existing domestic technologies. This radar can detect 40 targets, simultaneously track 10 targets, has track-while scan capability, and can attack 2 targets simultaneously. The tracking range for targets with a radar cross-section, RCS, of 3 square meters is about 90 kilometers in air-to-air mode and about 40 kilometers in air-to-ground mode. It features a bubble-style canopy that allows the pilot a maximum 360-degree field of view. The J-10 has a range of 1,850 kilometers and can reach a maximum speed of 2,327 kilometers per hour. The J-10 is a single-seat aircraft with delta wings, equipped with an AL-31FN turbofan engine. The airframe has a large vertical tail fin and canards near the cockpit position. There's a 2-seat version used for training and possibly ground attack missions. J-10B, an improved single-seat version. In the J-10B variant, the manufacturer replaced the old-style air intake with a supersonic diffuser intake. The J-10 has a length of 15 m and a wingspan of 9.75 m.
19 Sukhoi Su-57 Mach 2.0.
The Sukhoi Su-57 is a 5th-generation Russian fighter jet currently being developed under Sukhoi's leadership. It's the abbreviation for Perspektivnyi Aviacyjny Kompleks Frontovoy Aviacji, with the NATO reporting name Zfelin J. The current prototype is Sukhoi's T-50. When fully developed, the PAK-FA is intended to replace the MiG-29 Fulcrum and Su-27 flanker in Russia's arsenal and serve as the basis for the Sukhoi/HAL FGFA project being developed with India. As a 5th-generation fighter, it's designed to compete directly with the American F-22 Raptor and the multinational F-35 Lightning II. The T-50 made its first flight on January 29, 2010. The first production aircraft is expected to be delivered in 2019, with the second following in 2020. It features a breakthrough aerodynamic design. The Su-57 has a flying wing-style stealth shape, very different from previously manufactured aircraft. The weapon bay is under the fuselage, shielded by the pair of engines on either side, with the cockpit in front and tail at the rear. It has advanced radar and avionics systems. The Su-57 applies the latest technologies, including 6 radars to improve situational awareness, engines, and speed. The Su-57 can reach supersonic speeds of Mach 2.1 without afterburner. The fighter is designed for supersonic flight capability, maneuverability, stealth, and advanced avionics to surpass previous generation fighters, as well as ground and naval defenses. The Su-57 is intended to replace the MiG-29 and Su-27 in the Russian Air Force. Prototypes and initial production batches will be delivered with highly upgraded Saturn AL-41F1S engines as interim engines, while the modern advanced design engine is being developed. The aircraft is expected to have a lifespan of up to 35 years. The Su-57 controls stealth UAVs, a niche nightmare for any country's air defense, including Ukraine. Russian defense officials assert that the Okhotnik can operate under the control of Su-57 pilots. According to Vietnamese press, the Sukhoi T-50 is expected to be exported around 2025 to 2030 when it enters mass production in Russia. 18. Eurofighter Typhoon, Mach 2.0. The Eurofighter Typhoon is a multi-role fighter developed by the Eurofighter GmbH consortium through collaborative research. The Eurofighter Typhoon is a delta-wing, canard-configured multi-role combat aircraft. This design provides high maneuverability, low drag, and increased lift. The Typhoon has a length of 15.96 meters, a wingspan of 10.95 meters, a height of 5.28 meters, and a wing area of 50 square meters. Its maximum takeoff weight reaches up to 23.5 tons. The maximum flight speed of the Eurofighter Typhoon is about Mach 2.0 at high altitude, Mach 1.2 at sea level, and reaches Mach 1.3 at altitude with standard air-to-air weaponry. The Typhoon service ceiling can reach up to 19 kilometers, with an operational range of 1,390 kilometers and a climb rate of 315 meters per second. The aircraft is equipped with a 27mm automatic cannon with 150 rounds, operating on a pneumatic loading mechanism. Additionally, it has a total of 13 hardpoints, including 8 under the wings and 5 under the fuselage, allowing the Eurofighter Typhoon to carry up to 9 tons of various weapons. With the Captory active electronically scanned array radar system, the fighter can simultaneously track 20 targets with a detection range of about 160 kilometers. The Typhoon uses a highly sophisticated defense system called Praetorian. This system can detect and warn of threats from air-to-air and surface-to-air missiles. In combat, the Typhoon can use short-range air-to-air missiles such as Iris-T, AIM-9, AIM-132, and medium to long-range missiles like AGM-120 and MBDA Meteor. Furthermore, the Typhoon is equipped with short-range air-to-ground missiles AGM-65, the 500 km range KPD-350 cruise missile, Storm Shadow cruise missiles, and Paveway laser-guided bombs. The abrupt end of the Cold War reduced Europe's demand for fighter aircraft and led to debates about the cost and work-sharing of the aircraft, prolonging the Typhoon's development process. Kuwait and Qatar have also ordered this aircraft, bringing the total number of purchases to 623 as of 2019. The Eurofighter Typhoon is a highly maneuverable aircraft, designed to be an effective fighter in combat. Later production aircraft are increasingly better equipped to perform air-to-ground attack missions and are compatible with a growing variety of weapons and equipment, including Storm Shadow, Brimstone, and Marte-ER missiles. The Typhoon made its combat debut in the 2011 military intervention in Libya with the Royal Air Force and Italian Air Force, performing aerial reconnaissance and ground attack missions. This aircraft type also primarily serves air defense duties for most of its customer nations. 17. Dassault Rafale, Mach 2.0. The Dassault Rafale is a French twin-engine, delta-wing, multi-role fighter aircraft designed and built by Dassault Aviation. Equipped with a wide range of weapons, the Rafale is designed to perform air supremacy, interdiction, aerial reconnaissance, ground support, in-depth strike, anti-ship strike, and nuclear deterrence missions. Dassault refers to it as an Omnirole J-4.5th generation fighter. The Rafale has a maximum takeoff weight of 24.5 tons. It uses two Snecma M88 jet engines, each producing 48.7 knots of dry thrust and 72.9 knots with afterburner. The engines use a digital fuel control system that increases thrust, allowing the Rafale to fly at a maximum speed of up to 1,913 km per hour, with a combat range of 1,850 km. The Rafale is equipped with air-to-air and air-to-ground missiles, anti-ship missiles, anti-radiation missiles, as well as various types of bombs. Besides the French version, some export versions of the Rafale also carry the world's best air-to-air missile, the MBDA Meteor. In the late 1970s, the French Air Force and French Navy sought to replace and unify their existing fleets. To reduce development costs and promote potential sales, France signed an agreement with the UK, Germany, Italy, and Spain to produce a versatile future European fighter aircraft. Subsequent disagreements over work sharing and differing requirements led France to pursue its own development program. Dassault built a technology demonstrator aircraft that first flew in July 1986 as part of an 8-year flight test program, paving the way for project approval. The Rafale differs from other contemporary European fighter aircraft in that it is almost entirely manufactured by one country, with involvement of most of France's major defense contractors. Much of the aircraft's avionics and features, such as direct voice input, the RB-2AA active electronically scanned array radar, and the Optronique Secteur frontal infrared search and track sensor, were developed and produced domestically for the Rafale program. Initially planned to enter service in 1996, the Rafale experienced significant delays due to post-Cold War budget cuts and changing priorities. There are 3 main variants: the single-seat land-based Rafale C, the 2-seat land-based Rafale B, and the single-seat carrier-based Rafale M. Introduced in 2001, the Rafale is being produced for both the French Air Force and the French Navy's carrier operations. It has been marketed for export to several countries. The Rafale is considered one of the most advanced and capable fighter aircraft in the world and one of the most successful internationally. It has been used in combat in Afghanistan, Libya, Mali, Iraq, and Syria. 16. Dassault Mirage 2000, Mach 2.2. The Dassault Mirage 2000 is a French 4th-generation, single-engine, delta-wing, multi-role fighter aircraft produced by Dassault Aviation. It was designed in the late 1970s as a lightweight fighter to replace the Mirage 3 for the French Air Force. The Mirage 2000 evolved into a multi-role aircraft with several variants developed, with sales to a number of nations. It was later developed into the Mirage 2000N and 2000D strike variants, the improved Mirage 2000-5, and several export variants. Over 600 aircraft have been built and it has been in service with 9 nations. The Mirage 2000 has a length of 14.36 m, a wingspan of 9.13 m, a height of 5.2 m, and a maximum takeoff weight of 17 tons. The aircraft is equipped with a SNECMA M53-5 turbofan engine, allowing it to reach speeds twice the speed of sound. The combat range of the Mirage 2000 is 1,450 kilometers, with a service ceiling of 18,000 m and a climb rate of 285 m/second. The Mirage 2000 fighter can carry up to 6.3 tons of weapons on wing and fuselage hardpoints. The carried weapons include Mica or R-550 Magic 2 air-to-air missiles, as 30L air-to-ground missiles, and Exocet anti-ship missiles. Notably, it can carry 2 Scalp EG long-range cruise missiles. The Mirage 2000 is considered one of France's most successful multi-role fighter jets. Using the delta-wing interceptor concept from the Mirage 3, Dassault introduced a new design still employing this wing type. The delta wing is not ideal for maneuverability at low altitudes and short takeoff landing. However, it has advantages in high-speed flight characteristics, simplicity in manufacturing, and low radar cross-section. The Mirage 2000 is designed with a thin, low-set delta wing, swept back at 58 degrees, with 2 small canards in the front. The aircraft's center of lift is pushed forward, enhancing maneuverability. The fighter's airframe is designed with super-durable materials to operate in high-intensity combat conditions. The Mirage 2000 can be fitted with various radar variants, but the Thompson CSF RDM is most common. The target detection range is about 70 kilometers. It can track multiple targets and guide weapons to simultaneously engage two of them. French Mirage 2000 DS participated in the 2001 to 2002 intervention in Afghanistan, operating in conjunction with international forces and carrying out bombing missions with LGB-guided bombs. The Mirage 2000 also demonstrated good capabilities throughout the conflict, although the aircraft supplied to India had limited air interception capabilities and required significant modifications to drop conventional and laser-guided bombs. Two Mirage 2000 squadrons conducted a total of 515 sorties, and in 240 attack missions dropped 55,000 kilograms of weapons during this war. Simple maintenance despite a very high sortie rate made the Mirage 2000 the most effective fighter aircraft of the Indian Air Force in this conflict. 15. McDonnell Douglas F-4 Phantom II, Mach 2.23. The F-4 Phantom II is a long-range supersonic, all-weather, two-seat multi-role fighter-bomber aircraft designed and manufactured by McDonnell Douglas, initially for the United States Navy. The Phantom II was used by the U.S. military from 1960 to 1996 and was the primary air superiority fighter as well as the main fighter bomber of the U.S. Air Force. The F-4 was also equipped for the militaries of many other countries, and as of 2001, over 1,000 F-4 aircraft were still in use in 11 countries worldwide. The first F-4 Phantom II was designed as a fleet defense fighter and entered service with the U.S. Navy in 1960. By 1963, it was also being used by the U.S. Air Force as a fighter bomber. Until production ceased in 1981, 5,195 F-4 Phantom II aircraft had been produced, making it the most produced supersonic U.S. military aircraft. The F-4 also held the record for the longest continuous production of any aircraft, lasting 24 years until the F-15 Eagle was introduced. Improvements to the F-4 included the application of an advanced radar, using Doppler pulse and the widespread use of titanium alloy for the airframe. Despite its impressive size and large maximum takeoff weight, the F-4 could still reach a supersonic speed of Mach 2.23 and climb at 210 meters per second. Shortly after its introduction, the F-4 set 16 world records, including the absolute speed record of 1,606.342 miles per hour and an altitude record of 98,557 feet. Although these records were set in 1959 to 1962, 5 of the speed records remained unbroken until 1975. The F-4 could carry over 8,480 kilograms of various weapons on 9 hardpoints on its fuselage and wings, including air-to-air missiles, air-to-ground missiles, guided and unguided bombs, and nuclear bombs. Combat experience in North Vietnam led to the use of the Phantom II in both the U.S. Navy and Air Force as the primary air superiority fighter. The F-4 also had roles in tactical reconnaissance and suppression of enemy air defenses, which were used until Operation Desert Storm in 1991. The Mach 2 supersonic performance with long-range and heavy bomb-carrying capacity of the F-4 Phantom II became a template for the next generation of fighter aircraft in both heavy and medium/light categories optimized for daytime missions. In the U.S. Air Force, the F-4 was replaced by the F-15 Eagle and F-16 Fighting Falcon, and by the F-14 Tomcat and F/A-18 Hornet in the Navy, which continued the dual fighter attack role. The General Dynamics F-111 replaced the Phantom in the medium-range bomber role. Regarding costs, each F-4E was priced at $2.4 million. Each RF-4C cost $2.3 million. This price was quite high compared to fighter aircraft of that time. For comparison, the F-86 from the Korean War era would cost about $2.3 million in 2017 dollars. Thus, the F-4E was 8 times more expensive than its predecessor. 14. Lockheed F-104 Starfighter. Mach 2.24. The Lockheed F-104 Starfighter was an American single-engine supersonic interceptor aircraft widely deployed as a fighter bomber during the Cold War. Manufactured by Lockheed as a day fighter, it was one of the Century Series E of fighter aircraft for the United States Air Force. It was developed into an all-weather multi-role aircraft in the early 1960s and was produced by several other countries, being widely used outside the United States. The Starfighter had a breakthrough design, with thin, short wings attached further back on the fuselage compared to most contemporary aircraft. The wings provided supersonic performance and excellent high-speed, low-altitude performance, but poor turning ability and high landing speeds. This was the first production aircraft to reach Mach 2 and the first to reach 100,000-foot altitude after taking off under its own power. The Starfighter set world records for airspeed, altitude, and time to climb in 1958, becoming the first aircraft to hold all three simultaneously. It was also the first aircraft equipped with the M61 Vulcan automatic cannon. The F-104G version was sold in significant numbers to NATO air forces, where the fighter-bomber version continued to serve in most countries until the late 1980s. Despite its high accident rate, many NATO countries purchased it, and most of these F-104 purchases by these nations were associated with corruption. The issue was uncovered in 1975 when the U.S. Senate investigated Lockheed's bribery of officials in several countries to promote F-104 contracts. Lockheed developed the final and most advanced Starfighter version, the F-104S model, for use by the Italian Air Force, which was modified to carry AIM-7 Sparrow missiles. The Italian Air Force was the last user of the Starfighter, and they were retired in 2004. Many countries that used the F-104 later replaced them with F-16s or Panavia Tornadoes. Plans for a significantly improved version of the F-104, named the CL-1200 Lancer, did not progress and were cancelled at the prototype stage. 13. F-22 Raptor. Mach 2.25. The Lockheed Martin F-22 Raptor is the world's first fifth-generation fighter aircraft using stealth technology. Initially, it was designed to be an air superiority fighter against the Soviet Air Force, but was also equipped for ground attack, electronic warfare, and signals intelligence missions. With an extended development phase, the prototype of this aircraft was designated YF-22, then F/A-22 for 3 years before officially entering service with the United States Air Force in December 2005 with the official designation F-22A. Lockheed Martin is the prime contractor and is primarily responsible for the airframe, weapon systems, and final assembly of the F-22. Boeing provides the wings, aft fuselage, and integrated avionics systems. Only 187 F-22s were manufactured and commissioned into the U.S. Air Force, despite an initial plan for 750 aircraft. The F-22 order was reduced due to numerous issues and high costs. In 2011, the F-22 production line was closed. Instead of purchasing more F-22s, the U.S. invested in manufacturing the Lockheed Martin F-35 Lightning II, with the expectation that the F-35 would be less expensive. The F-22 is equipped with 2 Pratt & Whitney F-119 PW-100 afterburning turbofan engines integrated with thrust vectoring nozzles. The maximum thrust is classified, although most sources suggest it's around 35,000 lbf for each engine. The maximum speed is estimated at Mach 1.72 when flying in supercruise mode without external weapons. When using afterburners, the speed is greater than Mach 2.0, according to Lockheed Martin. The Raptor can easily exceed its design speed limits, especially at low altitudes. Maximum speed warnings help prevent pilots from exceeding these limits. Metz also said that the F-22 has a maximum speed greater than Mach 2.42 and its acceleration is greater than that of the F-15 Eagle due to advances in engine technology, even though the F-15's thrust-to-weight ratio is about 1.2 to 1, while the F-22's is close to 1 to 1. The true maximum speed of the F-22 is still unknown, as engine power is only one factor. The airframe's ability to withstand stress and friction-induced temperatures is a crucial factor, especially for an aircraft using many polymer materials like the F-22. It is one of the few aircraft capable of supersonic flight without using afterburners. The fuel consumption when using afterburners significantly reduces the aircraft's operational range. Supersonic flight altitude is also a very important factor in maneuvering. During exercises in Alaska in June 2006, F-22 pilots often took advantage of their altitude superiority to achieve unprecedented kill ratios.
12. Mikoyan MiG-29, Mars 225.
The Mikoyan MiG-29 is a twin-engine fighter aircraft designed in the Soviet Union. It was developed by the Mikoyan Design Bureau as an air superiority fighter in the 1970s. The MiG-29 entered service with the Soviet Air Force in 1983. Although initially oriented towards combat against any enemy aircraft, many MiG-29s have been equipped as multi-role fighters capable of performing a number of different operations and are typically outfitted to use various air-to-ground armaments and precision munitions. The MiG-29 has been manufactured in several major variants, including the Mikoyan MiG-29M multi-role version and the Mikoyan MiG-29K for naval operations. Later models often feature improved engines, glass cockpits with HOTAS-compatible flight controls, modern radar and infrared search and track sensors, and considerably increased fuel capacity. Some aircraft have also been equipped for aerial refueling. The MiG-29 SMT has a length of 17.3 m, a wingspan of 11.9 m, a maximum speed of Mach 2, and a service ceiling of 17,500 m. Compared to the original version, the weapon payload has increased from 3.5 tons to 4.5 tons with 7 weapon hardpoints. To improve the inherent weakness in the warning system, the Sukhoi radar has been installed on the new generation fighters, allowing the MiG-29 SMT to detect targets from a distance of 120 kilometers, simultaneously lock onto 10 targets and select to engage 4 of them at the same time. Notably, the upgrade of the electronic system allows the MiG-29 SMT to carry medium to long-range air-to-air missiles with active radar guidance R-77, air-to-ground missiles KH-29T/TE, supersonic anti-ship missiles KH-31A, anti-radar missiles KH-31P, and smart bombs. Of course, the modernized versions of the MiG-29 still cannot surpass fighters like the Su-35, but the retirement of this fighter is unlikely to happen in the near future. With Ukraine continuously urging its allies to transfer stored MiG-29s to Kiev to narrow the weapons gap with Moscow, the popularity of this fighter is likely to increase in the coming time. After the collapse of the Soviet Union, the militaries of many former Soviet republics continued to use the MiG-29, with the largest being the Russian Aerospace Forces. The Russian Aerospace Forces wanted to upgrade their existing fleet to the modernized MiG-29 SMT configuration, but financial difficulties have limited deliveries. The MiG-29 is also a popular export aircraft. More than 30 countries are using or have used this type of aircraft. As of 2024, Flight Global estimates that there are 809 MiG-29s of all types serving in air forces, making it the 5th most common fighter aircraft.
11. Sukhoi Su-35, Mach 2 y 25.
The Sukhoi Su-35 is a heavy, long-range, multi-role, air superiority 4th-generation fighter aircraft developed by Sukhoi. Due to its characteristics and components similar to the Su-30 Mki, the Sukhoi Su-35 is considered a sibling of the Sukhoi Su-30 Mki, a specially upgraded version of the Su-30. The Su-35 was further developed, resulting in the Su-35BM, later known officially as the Su-35S. The Su-35 is currently serving in the Russian Air Force, Chinese Air Force, and Egyptian Air Force. The T-10-24 test program was established in 1985. Test flights took off in 1988. The first prototype was publicly displayed in 1992 at the Farnborough International Airshow. The aircraft was initially named Su-27M, but was later changed to Su-35, although the name Su-27M still exists in the Russian military naming system. 11 prototypes were manufactured by 1994. It began experimental service in the Russian Air Force in 1995. The Su-35 has larger wings and more powerful engines than other variants of the Su-27 family. The Su-33 Flanker D and Su-35 share the same large wing and high-power engine design. Other changes from the Su-27 and Su-30 include canards, a larger nose, greater use of carbon fiber materials and lithium aluminum alloys in the airframe structure, and more square and wider tail fins. The front section houses an improved passive electronically scanned array radar. The aircraft has been updated with avionics technology and electronic systems, including a fly-by-wire digital control system and a rear-facing search and track radar for firing semi-active radar-guided missiles. It has an in-flight refueling system. Some individual parts and assemblies of the Su-35 fighter are being manufactured abroad, including in Ukraine. There, all the avionics in the cockpit are made based on foreign components. Dear friends, we have reached the halfway point in our exploration of the fastest aircraft in the world. But are you wondering, is speed everything? In today's era, with rapid technological advancements, we need to reassess the role of these weapons. Do they truly bring peace or merely escalate global tensions? Let's ponder this as we continue to explore the remaining 10 aircraft. Don't forget to leave your opinions in the comments section. Your participation will help us gain a more comprehensive view of this topic. 10. F-14 Tomcat, Mach 2.34. The Grumman F-14 Tomcat is a supersonic, variable sweep wing, twin-engine, two-seat fighter aircraft. Throughout its service in the United States Navy, it was used as a fighter, reconnaissance, bomber, and interceptor aircraft. It was developed following the failure of the General Dynamics F-111 Aardvark project and became the first in a series of U.S. fighter aircraft developed after air combat with Mikoyan aircraft in Vietnam. This fourth-generation twin-jet carrier-based multirole fighter/interceptor with variable sweep wings could reach speeds of over Mach 1 at sea level and over Mach 2.34 at altitude, thanks to its two General Electric F-110 GE 400 turbofan engines with afterburners. Additionally, the F-14 could fly approximately 2,500 kilometers without refueling, although experts believe its combat range was 1,600 kilometers. The aircraft could track 24 enemy aircraft up to 315 kilometers away using the X-band AWG-9 pulse Doppler radar, which employed one of the first microprocessors to appear on fighter aircraft at the time. Its powerful systems could even guide long-range missiles to 6 separate targets simultaneously without losing track of the remaining targets. Production began in 1969 and continued until 1991, with a total of 712 F-14s built. However, after the Soviet Union's collapse in 1991, the U.S. Navy found itself at a crossroads. At that time, with no more threatening shadow from Russian bombers to counter, the powerful F-14 became an unemployed warrior. In 2006, the F-14 was gradually phased out in favor of the cheaper Boeing F/-18E divided by F Super Hornet. The F-14 was introduced into the U.S. Navy in 1972, replacing the McDonnell Douglas F-4 Phantom II. It was retired from the U.S. Navy on September 22, 2006, and was replaced by the Boeing F/-18E divided by F Super Hornet. The F-14 was exported to the Kingdom of Iran in 1976, when it was still a close ally of the United States. Later, these aircraft were taken over and used by the Islamic Republic of Iran Air Force until they were retired in 2006 due to age and lack of spare parts. During the Iran-Iraq War of 1980 to 1988, Iran claimed that their F-14s shot down 160 Iraqi aircraft, at the cost of 16 Iranian F-14s. Today, an F-14 Tomcat plays a prominent role as an exhibit in the USS Lexington Aircraft Carrier Museum in Texas, and this aircraft has left an indelible mark on both the battlefield and world culture.
9. Su-27 Flanker, Mach 2.35.
The Su-27 flanker fighter is a product that the Russians inherited from the Soviet Union, and this fighter aircraft has undergone numerous upgrades and continues to serve with renewed strength. Although not everything the Russians inherited from the Soviet era and deploy today is impressive or effective, it is often assessed that Moscow has long held a good enough perspective on warfare. In addition to serving in the Russian Air Force and the air forces of former Soviet republics, the Su-27 has been widely exported around the world. Thanks to its two powerful jet engines, the flanker can reach a maximum speed of Mach 2.35 and has a range of 3,000 kilometers. Regarding armament, the Su-27 is equipped with a 30mm GSH 301 cannon and 150 rounds of ammunition. It has 10 hardpoints to mount various air-to-air missiles, as well as bombs and unguided rockets. The Su-27 can carry air-to-air missiles such as the R-27R1, R-73, and R-60, and upgraded versions are capable of using guided air-to-ground missiles and guided bombs for ground attacks. All of these weapons have demonstrated tremendous destructive power in numerous recent military campaigns conducted by the Russians, particularly in Syria and currently in Ukraine. However, the Russians have incorporated more than just fearsome weaponry into these war machines. Engineers have installed a range of defensive measures to ensure that the Su-27 can survive in any conflict longer than its adversaries. Furthermore, the Su-27 flanker fighter has the capability to operate in groups when working alongside other combat aircraft of the Russian aerospace forces. This group combat capability enhances the survivability of these aircraft. Systems such as radar warning receivers, countermeasure devices to confuse incoming missiles, and multi-mode jamming technology all support the Su-27's survivability in combat. The Su-27 fighter has broken many aviation records since it first entered hostile skies after its official introduction in 1985. All these factors have led to a heated debate in military aviation circles about whether the Su-27 flanker or the U.S. Air Force's F-15 Eagle is the superior fighter aircraft. This debate is necessary, given the tense relations between Russia and the United States. After all, the US-built F-15s may one day face off against Su-27s in the sky. It's understandable that many people want to know which fighter is better. The Su-27 has a slightly better thrust-to-weight ratio than the F-15, and the maneuverability of both aircraft is quite comparable. However, the Eagle's weapon load capacity surpasses that of the flanker. Above all, the avionics systems of the American fighter are believed to be far superior to those of the Russian aircraft. This is crucial as modern air combat primarily occurs beyond visual range, clearly giving the F-15 an on-paper advantage. 8. General Dynamics F-16 Fighting Falcon, Mach 2.4. The F-16 Fighting Falcon is a multi-role jet fighter aircraft produced by General Dynamics and Lockheed Martin specifically for the United States Air Force. Designed as a lightweight fighter, it has become a highly successful multi-role combat aircraft. Its versatility and relatively low cost have contributed to the F-16's success in the export market, and it is currently in use by 24 countries. As of 2016, the F-16 program is the largest Western fighter program, with over 4,500 aircraft built since production began in 1976. Although it is no longer being produced for the U.S. Air Force, it continues to be manufactured for export. In addition to serving in regular Air Force units, the Air Force Reserve Command, and the Air National Guard, the F-16 is also the official demonstration aircraft for the U.S. Air Force Thunderbirds and is used as an adversary aircraft for training by the U.S. Navy. The Fighting Falcon is a successful fighter with many advanced features, such as an all-glass bubble canopy for improved visibility, a side-mounted control stick for easier maneuvering under high G-forces, and a reclined seat positioned at a 30-degree angle to reduce the effects of G-forces on the pilot. It is also the first fighter aircraft purposefully designed to withstand up to 9 G-turns. The F-16 is one of the few jet fighters with a thrust-to-weight ratio greater than 1, providing the Falcon with excellent acceleration capabilities. Despite its official name Fighting Falcon, the F-16 is often affectionately referred to by pilots as the J-Viper, a nod to the Battlestar Galactica sci-fi series. In 1993, General Dynamics sold its aircraft production facilities to Lockheed Corporation, which later became part of Lockheed Martin after a merger in 1995 with Martin Marietta. Alongside its advantages, the F-16 F-16 also has drawbacks, including a relatively high rate of incidents and accidents. As of May 2023, the F-16 holds records for both the number of accidents and the accident rate among popular fourth-generation fighter jets worldwide. There have been 895 F-16s involved in accidents, averaging 22.4 accidents per year globally. Of these, 659 F-16s were completely destroyed, meaning for every 7 F-16s produced, more than one has been lost due to accidents. This accident rate is higher compared to other contemporary aircraft like the F-15, F/A-18 Hornet, Su-27, and MiG-29. 7. F-15 Eagle, Mach 2.5. Developed based on the multi-role F-15 QA fighter version, which is an upgrade from the F-15E Strike Eagle sold to Qatar by the US, the F-15EX has fully utilized all the advantages of this very successful heavy fighter series. Boeing states that although the F-15EX was developed from the F-15 QA version, they had actually been quietly developing it during the period from 2010 to 2020. Specifically, the U.S. Air Force has ordered the first batch of 8 F-15EX aircraft with a total value of $1.2 billion. Subsequently, they approved a plan to purchase an additional 136 units in the following fiscal years. On April 7, 2021, the F-15EX fighter jet was officially named Eagle II. The U.S. Air Force plans for the F-15EX Eagle II to replace the F-15C Eagle and F-15E Strike Eagle squadrons. It's easy to see that the cockpit of the F-15EX version has been refreshed, applying many achievements from the fifth-generation fighter, the F-35. The F-15EX is also equipped with an active electronically scanned array radar with extremely high sensitivity, helping it easily detect and lock onto targets. The electronic warfare system on the F-15EX is expected to defeat new air defense missiles and interact well with other U.S. military sensor systems to maximize survivability. Another outstanding feature of the F-15EX is its weapon payload. While most fighters only carry a weapons load ranging from 6.5 to 8 tons, the F-15EX can carry up to 14 tons of weapons. This new version can carry up to 24 missiles, twice as many as Russian aircraft. To date, no other fighter jet has been able to carry as many missiles. This fighter can carry more missiles due to a special multi-level rack, which is a new invention by the American weapons manufacturer Boeing. These multi-level launch racks allow the F-15EX to carry an extremely large number of missiles, while not significantly affecting the aircraft's aerodynamic performance. In terms of maneuverability, the F-15EX still maintains a speed of Mach 2.54 thanks to the tuning of the F-100-229 F-135 engine, which significantly increases thrust. The aircraft's climb rate reaches 250 meters per second, with a service ceiling of 18.5 kilometers and a range of up to 3,900 kilometers. The M61A Vulcan cannon is retained in the wing recess for short-range air combat or fighting when all missiles have been expended. Although we have entered the era of fifth-generation fighters prioritizing stealth capabilities, the drawback of this generation of fighters is their low weapon payload, lower maneuverability, and speed. Additionally, they have high operating costs. The F-15EX compensates for these issues with its large weapon payload, high maneuverability, and lower operating costs compared to fifth-generation fighters. It is predicted that the F-15EX Eagle II fighter will continue to achieve resounding success in the export market like its predecessors, the F-15 Eagle and F-15E Strike Eagle. 6. Convair F-106 Delta Dart, Mach 2.5. The Convair F-106A Delta Dart was an all-weather interceptor aircraft operated by the United States Air Force from the 1960s to the 1980s. Designed as what was called the Ultimate Interceptor, it was the last dedicated interceptor fighter to serve in the U.S. Air Force to date. It was gradually retired in the 1980s, although the QF-106 variant, which served as a target drone, was used until 1998. The aircraft underwent so many modifications and changes in design that it essentially became a new design in itself, and was renamed the F-106 on June 17, 1956. The aircraft body was smoother and simpler in many ways, with modified wings having a slightly larger wing area and redesigned tail surfaces. The fuselage was also slightly shorter compared to the F-102 Delta Dagger. An F-106A Delta Dart of the California Air National Guard firing an Air-2 Genie nuclear missile. Initial test flights in late 1956 and early 1957 were disappointing, with flight performance much lower than expected, but after the program was nearly cancelled, the Air Force decided to order 350 F-100 and SEXS instead of the 1,000 originally planned. After some minor design changes, the newly named F-106A was delivered to 15 interceptor squadrons, along with the EF-106B variant starting in October 1959. In December 1959, Major Joseph W. Rogers set a new world speed record of 2,455.79 km per hour, while flying a Delta Dart at an altitude of 12,300 m. The F-106 was equipped with the Hughes MA-1 integrated fire control system, which could connect to the semi-automatic ground environment network for ground-controlled interception missions. It was armed with 4 air-to-air missiles intended to be fired at enemy bomber formations. The MA-1 fire control system was prone to malfunctions and later had to be upgraded more than 60 times during its operational life. 5. F-111 Aardvark, Mach 2.5. The General Dynamics F-111 was a medium-range strategic bomber, reconnaissance, and fighter aircraft designed in the 1960s. The F-111 Aardvark could carry up to over 14 tons of weapons suspended from its wings and within its fuselage. Besides bombs, it could also carry air-to-air missiles, air-to-ground missiles, and even cannons. The F-111 Aardvark was equipped with 2 Pratt & Whitney TF-30P100 turbofan engines, each producing 19.4 knots of thrust. With afterburners, the thrust increased to 112 knots, allowing it to reach speeds of up to 2.5 times the speed of sound, or about 3,000 kilometers per hour. The F-111 Aardvark had a crew of 2. Its operational range was up to 5,190 kilometers, with a service ceiling of 17.27 kilometers. The length of the F-111 Aardvark was about 22.4 m. Notably, its wings could sweep back or extend depending on its flight mode. Besides bombing missions, the F-111 Aardvark was also designed for reconnaissance and surveillance. One of the primary requirements was that it should be very fast. General Dynamics Corporation researched and developed this aircraft for the U.S. Air Force in the 1960s. The version for the U.S. Air Force was officially named Aardvark, a long-time nickname, in a ceremony in 1996 when it was retired. It continued to be used by the Royal Australian Air Force, where it was called the E-Pig, until its final retirement after December 3, 2010. The F-111 pioneered several military aircraft production techniques, including variable sweep wing design, afterburning turbofan engines, and terrain-following radar for high-speed, low-altitude flight. During the Vietnam War, one F-111 crashed due to a tail failure caused by a crack from a weld, and a few months later, another aircraft crashed for the same reason. One of the many known types of accidents was wing failure during flight. One aircraft with less than 100 flight hours crashed because its wing had developed a small crack during missile testing, which rapidly deteriorated. These accidents led to other F-111s being subjected to further testing before being allowed to fly again. As a result, several more aircraft were severely damaged during stress testing. 4. Mikoyan-Gurevich MiG-25, Mach 2.83. The prototype of the MiG-25 fighter was codenamed E-155P-1 and made its first flight in September 1964. Initially, engineers at the Mikoyan-Gurevich Design Bureau faced a challenging task: to create a fighter that could contend with the American supersonic B-58 bomber and State Route 71 Blackbird reconnaissance aircraft. This third-generation fighter could reach speeds of up to 3,000 kilometers per hour, an incredible feat at the time. Moreover, it achieved this with a full weapons load, 4R-40 air-to-air missiles. However, this wasn't the only feature that made the Soviet fighter stand out. In total, the MiG-25 interceptor held 38 world records. One of these was flight altitude. In 1977, pilot Alexander Vasilyevich-Fedotov raised the fighter to a record altitude of 37,650 meters. Even modern fifth-generation fighters like the American F-22 Raptor are not capable of this. Unsurprisingly, the new Soviet fighter created a huge demand. A total of 1,190 were produced with various modifications from 1966 to 1982. The MiG-25 Foxbat not only served in the Soviet Air Force but was also present in the combat units of Libya, Iraq, Iran, Bulgaria, and Algeria. During the Desert Storm campaign launched by the U.S., a MiG-25 serving in the Iraqi Air Force shot down a carrier-based F/A-18 Hornet fighter in an air battle. The Foxbat also stood out in the conflict between Egypt and Israel from 1967 to 1970. During this conflict, the Soviet interceptor was used extremely successfully by the Egyptian Air Force. In fact, the inherent potential of the MiG-25 allowed for deep modernization, and the operation of this aircraft could potentially continue even to the present day. However, the fate of this unique warrior was decided by chance. In 1978, a Soviet MiG-25 was hijacked by Lieutenant Viktor Belenko, who flew it to Japan during an exercise. The aircraft was then handed over to the Americans for detailed study. The U.S. returned the aircraft to the Soviet Union 2 months later. However, during this time, the fighter had been thoroughly examined by opposing engineers, so major secrets were no longer kept, and the MiG-25 was retired relatively early. The MiG-25 interceptor, according to many military experts, possessed unique characteristics that were significantly ahead of its time. 3. Mikoyan MiG-31. Mach 2.83. The Mikoyan MiG-31 is a supersonic interceptor aircraft developed to serve the Soviet Air Force, replacing the MiG-25 fighter. The first flight of the Mikoyan MiG-31 took place in September 1975. The MiG-31 is considered one of the fastest fighter aircraft in the world and is expected to continue operating until at least the mid-2030s, according to National Interest. The MiG-31 fighter is equipped with a modern digital avionics system and has 2 seats, with the rear seat occupied by an officer responsible for the dedicated weapons system. The airframe consists of 49% nickel steel welded by arc welding, 33% light metal alloys, 16% titanium, and 2% composite materials. The fighter is equipped with a special turbofan jet engine, allowing for an increased combat range. A key point is that the MiG-31 fighter plays an important role in helping the Kinzhal missile achieve hypersonic speeds. The missile carried on the MiG-31 fighter will be launched from an altitude of about 20 kilometers above ground level and at a speed of at least 1,500 kilometers per hour. The speed of this fighter allows the Kinzhal to reach its maximum speed, 8 to 10 times the speed of sound, making the missile highly lethal and almost impossible to intercept. The upgraded MiG-31BM version uses long-range R-33 air-to-air missiles and short-range R-73 air-to-air missiles. The MiG-31BM is equipped with 2 D-30F6 engines, with a maximum speed of 3,000 km per hour, a service ceiling of 20,600 m, and is fitted with an in-flight refueling system. Although the MiG-31 fighter was not developed for close combat or quick turns, it was the first Soviet fighter aircraft with look-down/shoot-down capability. The MiG-31's Zaslon radar was the world's first phased array radar with a range of 200 kilometers. It can track 10 targets simultaneously and control the attack of 4 of these targets at the same time. Because this supersonic fighter is capable of carrying the Kinzhal ballistic missile, whenever a MiG-31 takes off from a Russian military base near Ukraine, an air raid warning is issued across the entire country, sometimes lasting for hours. 2. XB-70 Valkyrie. Mach 3.1. Developed with the goal of replacing the B-52 Stratofortress and B-58 Hustler, the XB-70 Valkyrie was designed to penetrate Soviet airspace at high altitudes with speeds up to Mach 3. The U.S. Air Force hoped the XB-70 would become a symbol of their future power at that time. The design of the XB-70 Valkyrie resembled a spacecraft more than a bomber, and the military even nicknamed this weapon the J-Mafia bomber. The XB-70 Valkyrie was a supersonic strategic bomber jet developed by the U.S. Air Force from the late 1950s and made its first flight in 1964. At the time of its debut, the XB-70 Valkyrie was the fastest aircraft in the world. To achieve such a breathtaking speeds, the XB-70 Valkyrie was equipped with 6 GE YJ-93 GE-3 jet engines. The GE YJ-93 GE-3 jet engine had the highest thrust and was the most advanced at that time, with a dry thrust of approximately 84 knots and an afterburner thrust of up to 128 knots each. The United States spent about $1.5 billion at that time, equivalent to about $11 billion today, on this project with only 2 XB-70 Valkyries completed. Thus, each one was worth over $5.5 billion at today's prices. The current American stealth bomber, the B-2, costs only $2.1 billion. Due to the high costs, the 2 XB-70 Valkyrie jets were jointly used by both the U.S. Air Force and NASA. With its high speed and high altitude capabilities, NASA used the XB-70 Valkyrie to simulate weightlessness in outer space. The XB-70 Valkyrie had an empty weight of 115 tons and a maximum takeoff weight of 246 tons. It had a maximum speed of Mach 3.1, a cruising speed of Mach 3.0, a range of 6,900 kilometers, and a ceiling of about 23,000 meters. Although the XB-70 project was cancelled, 15 years later, the technical advantages of this aircraft were successfully applied by the U.S. to the B-1B Lancer bomber. 1. Lockheed State Route 71 Blackbird Mach 3.3+. The Lockheed State Route 71A Blackbird E is a retired long-range, high-altitude, Mach 3+ strategic reconnaissance aircraft developed and manufactured by the American aerospace company Lockheed Corporation. The State Route 71 had several nicknames, including Blackbird E and Jahabu. The State Route 71 was developed as a black project from the Lockheed A-12 reconnaissance aircraft in the 1960s by Lockheed Skunk Works Division. American aerospace engineer Clarence E. Kelly Johnson was responsible for many of the aircraft's innovative concepts. The shape of the State Route 71 was based on the shape of the Lockheed A-12, one of the first aircraft designed with the purpose of reducing radar cross-section. Initially, a bomber variant of the A-12 was requested by Curtis LeMay, before the program focused solely on reconnaissance. The State Route 71 was longer and heavier than the A-12, allowing it to carry more fuel and have a 2-seat cockpit. The existence of the State Route 71 was publicly announced in July 1964. It entered service with the United States Air Force in January 1966. In 1989, the USAF retired the State Route 71, primarily for political reasons. Some were briefly reactivated in the 1990s before being retired again in 1998. NASA was the final operator of the Blackbird, using it as a research platform. It was retired once more in 1999. The mission equipment for the aircraft's reconnaissance role included signal intelligence sensors, a side-looking airborne radar, and a camera. During its missions, the State Route 71 operated at high speeds and altitudes of Mach 3.2 and 85,000 feet, allowing it to outrun or entirely avoid threats. If a surface-to-air missile launch was detected, the standard evasive action was simply to accelerate and outpace the missile. On average, each State Route 71 could fly once a week due to the extended turnaround time required after mission recovery. A total of 32 aircraft were built. 12 were lost in accidents, and none were lost due to enemy action. Since its retirement, the SR-71's role has been taken over by a combination of reconnaissance satellites and unmanned aerial vehicles. A proposed successor UAV, the State Route 72, is being developed by Lockheed Martin and is expected to fly by 2025. As of 2024, the State Route 71 holds the world record, set in 1976, for the fastest air-breathing manned aircraft, previously held by the closely related Lockheed YF-12. So we've just reviewed the 20 fastest fighter jets in the world. It's truly amazing to see the advancements in military aviation technology, isn't it? From the aircraft in the 20th position to the lightning-fast machine in the #1 spot. These marvels were created with the hope that they would never have to be used in actual combat. They serve as tools of deterrence, protecting global peace. If you enjoyed this video, don't forget to like and subscribe to our channel so you don't miss out on more exciting content. What do you think about this list? Is there any aircraft you would like to add? Share your thoughts in the comment section. Thank you for watching. See you in the next video.